Okay, my friends, this is going to be fun. Why do we get old? Everybody gets old. It's just a fact of life. But why? I've been looking into this, and I think I uncovered some things that are kind of hard to believe, but I believe they are true. So I was just doing a series on this, and today pops up a video of a documentary. It just came out an hour or so ago, and I'm going to go into it. And I figured, well, what the heck? I'm going to tape it while I do it and make comments about it. You know, this is under the Fair Use Act. I'm not trying to steal anything. I just want to see if we can all learn something from this. That's all. Okay, so the topic is health, and what makes you healthy is your organ systems working correctly. And there you are loaded with organs: your pancreas, your liver, your kidneys, your lungs, your heart, you know, all of these different things, your intestines, your small intestine, large intestine, everything. It all has to work together, and they all have one thing in common. All right? I'm not going to tell you what that is until later. Okay, so here we are at DW Documentary. This young lady seems like she's going to really do something in life. Very young, but understands about, you know, biology and physiology and so forth. And it sounds like chemistry as well, which you need to have all of that stuff to be able to make good decisions. You can't just say, I know one specific thing and I have to rely on everybody else. You have to be able to rely on yourself to come up with good conclusions. And she's got a bunch of little friends here together. Here they are talking about it. And they're going to be talking about proteins. Proteins are the building blocks of life, and they are enzymes and catalysts. That's the key. When you just say protein, well, what's a protein? It's just like some piece of meat. No, it's not. The proteins we're talking about are catalysts and enzymes, which are literally chemical factories. Absolutely stunning what they can do. In 1 second, millions of chemical breakdowns with one single molecule can do millions in 1 second. Now, they're talking about eradicating aging. I don't think you can do that. I think you have an expiration date, and they talk about that later in here, how many years a certain species lives. And they say in us, 122 years is the top, they say. Now, here it goes. Listen to this now.
When she's not in school, Nina holds talks around the world. She's launched a small startup with a couple of friends. The group searches for scientific clues on how to crack the aging code.
Yeah, I can work on that side. One of our proteins is probably involved with that process.
All right there. I'm just going to stop it right there. One of our proteins is probably involved in that process. Proteins, let's look into the proteins. All right, you heard what she said. It probably involves a protein. Yes, she's correct. Enzymes are proteins. They speed up metabolism or the chemical reactions in our bodies, and I mean they rocket ship them. They build some substances and then they break other things down. You have to break down things to make it digestible. They do that by these enzymes and catalysts. And the other times they build molecules to make things like bone and so forth. All living things have enzymes. All living things. Now, what are enzymes? Pancreas, digestive system, liver functions, all involved. And where do they come from? Where do enzymes come from? All right, so we know that proteins are involved in these things. Proteins are created by bacteria. Bacteria are the factories that produce enzymes. Enzymes are the things that do all the breakdown of the products and building of the products, mucus, so forth. That's all created by enzymes, and that's created by bacteria. And the bacteria create these proteins. They're very, very exotic little molecules that can break things down millions of times in 1 second and not even be consumed themselves. They're that powerful, absolutely incredible. All right, they're talking about people who live to be 100 years old. This guy here apparently did, and he's being honored and so forth. But I can tell you what, his immune system, he probably never had antibiotics in his life. He was probably best breastfed, well, obviously, vaginal birth, I'm sure, and he lived on a farm probably. He ate dirt all day long, and he had plenty of immunities in his body, and so he's got a healthy immune system.
One of the interesting things about supercentenarians and centenarians is that their immune systems last much better than the rest of us, which is a clue as to the fact that you need to have a good immune system in order to stay alive a long time.
Exactly. Okay, I'm just going to play this. He's going to be talking about thymus rejuvenation. And this is very interesting.
I already said yes,
Steve Horvath compared blood samples from the test subjects before and after treatment.
And he was just as amazed, if not more amazed, as we were about the results.
If they are confirmed, it will be a sensation.
The original intention was get rid of the fat of the thymus. This treatment had a side effect, an unexpected side effect. It really rejuvenated the methylation, the epigenetic clock.
All 9 test subjects turned their epigenetic clocks back by around 18 months in a year of treatment. That means they had essentially reversed their biological age by 2.5 years.
We began to get reports from some of the people in the trial that I feel great, I feel so energetic now. I feel my mind is working faster than it's worked before. Before the trial was over, this volunteer says, my wife has been telling me that my hair's growing in dark again. And I said, really? That's interesting. Let's have a look. So we looked at his hair, and boy, it was a big, very strong difference. His hair was darkening all over the place.
I need to say, we are all very excited about it, but we are also very sober scientists, and therefore we always felt we desperately need a second validation study. And that's really why I continue to work with Greg, why I become a study participant.
A third study with more test subjects aims to corroborate the original results.
All right, I'm just going to cut it off here. And what I want, and that's absolutely fabulous. I'm not sure what this treatment is, to be perfectly honest with you. I have to look. They've talked about it, but I don't think I saw any real hard statements about exactly how they did it. But I'm sure I can get some more information on that. However, fecal matter transplants, all right, which is the microbiome. Just take good microbiome from a healthy person, make sure it's got no pathogens, no bad things in it, transplant that into a good healthy person. Literally within hours almost, they have reported feeling significantly better and having extreme diseases. Crohn's disease, where they're going to have their bowel removed, or intestine, or whatever it is they do. But the digestive system is delicate. It has to be protected by all of these microorganisms, which are bacteria. Once the bacteria are dead for whatever reason, antibiotics primarily, but a lot of other things, and aging, they just get old. And if you take an old mouse and you put young fecal matter into him, he gets younger. 2 specific things happen they know of, is the eyes get better and the brain gets less reactions going on. It calms the brain down. And I've been getting a lot of reports, because I've got 150,000 people that, I've been talking about this for quite some time, and we've been doing a lot of research on probiotics. Now, the fecal transplant is a much, much better process, because the depth of which these little microbes can hide is in between all the villi. There's all these little tubes sticking up, and right down in the pockets, they get down in there and they hide in there covered with mucus. The drugs can't penetrate. However, good bacteria has a flagella, and it goes right down into it, kills it. All right, so let's just take it a little further.
The cell division, the cell multiplication. So at the end, the telomeres become so short, and we don't have anymore a telomere. So now our DNA is unprotected, and this is leading to aging, it's leading to disease, and ultimately will be leading to death.
Cell division and the rate of telomere shortening may be influenced by our lifestyle.
Exactly. Your gut microbiome is your immune system.
Smoking, stress, environmental pollutants, and poor nutrition are all negative factors. Some researchers believe living in harmony with the natural world has a positive effect.
These people that are living to be 100, they live isolated from the rest of the areas. That's why this pocket has stayed this way.
We couldn't carry out experiments like this in Costa Rica, so we sent our samples away. When the results of this collaboration came back, we realized we'd found something. People from Nicoya have longer telomeres, significantly longer telomeres than people in the rest of the country.
Scientists like Maria Blasco are exploring ways of artificially lengthening telomeres in order to slow the aging process. But this does come at a risk.
The danger is that cancer can develop, because cancer cells are immortal. And
See, this is the issue. A lot of these interventionist therapies come with such extremely heavy price tags of other diseases and other infections and other possible negative outcomes, that when after you hear the list of side effects, you say, whoa, what am I taking it for if all that stuff is possible? And it is in most cases. Chemotherapy is not a selective therapy. It is like a machine gun approach to taking out all kinds of biology and bacteria that could be good, could be bad. But when you take out the good stuff, you're in trouble. You got to put it back. And if you take it out and it repopulates with bad stuff in an area that can't be accessed by the drugs they're giving you, and that's pretty much what it is. The drugs can't even get to that particular place because these these organisms are so deeply embedded into the villi and everything. They're coated with all kinds of stuff. You can't get to them. They live down there. The only thing they can swim down is something with a flagella. Swim right down there and kill them. And that is another bacteria.
How far can we go? How much should science interfere in nature's blueprint?
We don't have to necessarily accept current biological limitation, because that's what we do as a species. We're problem solvers. We don't just sit around and get rained on, we build houses. So we may want to transcend normal biology at some point and set goals for ourselves beyond just normal concepts of health.
All right, all I'm asking is to take a look at the normal, young, productive, healthy microbiome that had all of the immune system programming, because that's what it is, programming. They're right, it is programming. When you are born, the first thing that has to happen is you have to be born from a healthy mother. And then you need to have a vaginal birth where you get slathered with all of that bacteria that's in the vaginal canal. And then you need to be literally covered with feces as well. It's all part of that same process right there together, and you want both of those things. Then the baby should stay in that for a period of time, maybe even an hour, with not being too well cleaned up. And let that stuff soak in. Literally, I'm telling you, because when they're born, they have no immune system whatsoever. Now next you have to have a mother that's given colostrum, or whatever how I pronounce it, which is the really heavy-duty mother's milk that the baby needs in that first few days, absolutely essential. And then the mother's milk changes as they go forward. This is all a program. It knows, say, oh, hey, the baby's done. All right, get that colostrum working. Yep, okay, no problem. Give it 4 or 5 days, see how the kid's doing. And there is communication back and forth between the baby and the nipple, I'm sure. There's so much going on in our bodies that we don't understand, working with these enzymes and bacteria. Bacteria know each other. They know how to work with each other. You need bad bacteria and you need good bacteria in your same body. And the reason you need that is because the bad bacteria has to get rid of some of your bodily tissues that you normally don't want to get rid of. All right, it's got to go and break them down and clean them out and throw them out. But you don't want to go throw them out. Good tissue, which is cancer, that's the attack mode. You want the correct molecules, the correct bacteria in your body to work on the signals that the cells send. There's a cell that's sent from a dying cell. It doesn't just die and one day it's here and the next day it's dead. They send off a little tiny chemical signature that says, I am in the process of dying. A bacteria will recognize that chemical signature, which literally is magnetic. It's a ton of little magnetic spots. And it'll see that and it'll latch right onto it. It'll turn it into goo. And then it'll bring it over through your lymph nodes and you'll work it out through your system and it'll go to it'll be flushed out of your system because it's being broken down. But if you didn't have that bad bacteria to break it down, it wouldn't break down. So you got to have good and bad, but you can't have the bad take over the good.